Hello, welcome to my Pre-Algebra review series. This video covers Chapter 6, Section 3, titled Similar Figures and Scale Drawings. By the end of this section, you will have reviewed the procedures for using similar figures and using similar figures to solve real-world problems. Finally, you'll be reviewing the use of scale drawings. Please leave a like if you find this video to be helpful. Give your classmates a heads up too. It will more than likely help them, and it certainly helps this channel to be seen by more students. If you'd like me to cover any of these topics in greater detail, please leave a comment in the comment section below. I read them and do my best as time permits. Please subscribe to my channel and ring the bell icon to be notified every time I release a new video. Thank you very much. Definitions. Similar figures. Similar figures have the same shape, but not necessarily the same size. Similar figures have corresponding angles and corresponding sides. The symbol, this tilde right here, this symbol right there, means similar to. Indirect measurement. You can use similar figures to compute the distances that are difficult to measure directly. Such a process is called indirect measurement. Scale drawing. A scale drawing is an enlarged or reduced drawing that is similar to the actual object or place. The ratio of the distance in the drawing to the corresponding actual distance is the scale of the drawing. So if you had a drawing that was drawn 1 inch for every foot, or 1 inch per 100 feet. So when you draw a straight line on your drawing with 1 inch, that would mean 100 feet. And that would be the scale, 1 inch per or 100 feet per inch. That's kind of how they would do that. Okay. Objective 1, using similar figures. Similar figures have the same shape, but not necessarily the same size. Similar figures have corresponding angles and corresponding sides. We talked about that in the definitions. The symbol right here, this tilde, means similar to. At the right, triangle ABC, right here, ABC is approximately, here's a little tilde, approximately equal to or similar to XYZ. I said approximately the other day. I really meant the other moment ago. It's really similar to, not approximately. It means similar to. So here the triangles are on this side. Here's ABC. I'm going to change my color here. So here's ABC over here, and there's X, Y, and Z. As you can see, they're similar. They have an X, Y, and Y, Z, and the shapes are the same, basically. The ratio of 6 to 8 for this size over here is the same as 9 to 12. They're both 3/4. So that's the similarities. They're different sizes, but they're similar. So key concept of similar figures. Similar figures have two properties. Right here, corresponding angles have equal measurements. So these angles, angle A over here is 53 degrees. Angle X over here is 53 degrees. The sides might be different, but they're in a relationship. They're proportional to each other. The lengths of the corresponding sides are in proportion. So that's really the difference. That's what makes the triangle, in this case, the triangle, larger or smaller. Okay, example 1, using similar figures. So we're given the fact that parallelogram ABCD, okay, that's this one here, is equal to EFGH. EFGH, that's this one over here, these are similar. Right here it says that they are similar. So what does that mean? It means that the angles are identical and that the sides are in proportion. They're relatively proportional, or they're proportional to each other. So that means we can write a proportion for the corresponding sides. And apparently we're going to want to find X. Just find the value of X. So let me say this much, that when you're trying to find the value of X in this case, it's best if you have the freedom to write it the way you'd like, you should write when you write your ratio, put the X on top in the numerator. So that would be something like this. We'd say, I'll put it right here. X over 16 is equal to 18 over 24. And the beauty of this is that the X is in the numerator already. That means that you don't have to move it. The only thing you're going to have to do is multiply both sides by 16 to get rid of the 16 in the denominator. And so you do that, you would say 16 times x over 16 is equal to 18 over 24 times 16. Well, now the 16s over here cancel, so you end up with the x equals 18 times 16 divided by 24. And if we take and get out the calculator on that, we'll find that 18 times 16 divided by 24 is equal to 12. So what we're finding is that x equals 12. So I'll write it right here. X equals 12. Okay, so side DA and HE. DA, that's this side here, x. Okay, and HE, the A size 18 here, that they correspond. They say they correspond because why? Because these fractions are similar. If we say 12 to 16 is 3/4, 18 to 24 is also 3/4. So 12 divided by 4 is 3. 16 divided by 4 is 4, 3/4. 18 divided by, well, now it's not going to be 4 anymore. Divided by 6 is going to be 3. And 24 divided by 6 is going to be a 4. So they're both 3/4. Okay, and then it says sides A, B, and EF correspond using cross product. So let's say if we do that, if we say that 12 over 16 are equals, and then it's 18 over 24, we would find that if we do the cross product on these, 12 times 24 is identical to 16 times 18. And whatever that number comes out to, let's go ahead and give it a shot. I'll clear the calculator here, and we'll say 12 times 24 is 288. So it's 288. I'm going to write down 288 here. 288. And 16, let me clear the calculator here. 16 times 18, lo and behold, is 288. So those are true. They're equal to each other. And I'm sorry, I don't have a calculator that I can bring up on my screen. If I could, I would, but I don't have one that I can bring up. So I had to do the calculator on the side. Okay? Okay, example 1, check your understanding. It says directions. Parallelogram KLMN is similar to parallelogram ABCD in example 1. Well, our example is right here, example 1. Find the value of y to the nearest tenth. So let's give it a try, and we'll see how first of all, you should give it a try. It's check your understanding. Go ahead and pause. Come on back when you're ready. Okay, now that you're back, let's give it a run. Let's run. Let's do NK divided by KL. So NK divided by KL is where we have y over 21 equals 18 over 24. And it's the same thing. It equals to 18 over 24. And if we multiply the 21 times 18, we're going to get, to clear the y, to get the y by itself, we're going to multiply by 21 times y over 21, and that equals 18 over 24 times 21. Okay, and 18 times 21 okay, having used the calculator here now, we're going to find out that y is equal to 18 times 21 is 378. 378 divided by 24, and that equals 1575. Well, it says round to the nearest tenth, so y is equal to 15 75 rounds to 0.8. Okay, 15.8. That's rounded to the nearest tenth. And what we did is we just wrote the ratio y over 21, right? And then we had to cancel the 21 with the y. So and basically, after you write both ratios and then multiply both sides by the 21, you just finish the multiplication and you have the answer. And you can go back and look at that again if you want to watch it. Okay, example 2, real world problem. You can use similar figures to compute distances that are difficult to measure directly. Such a process is called indirect measurement. A tree casts a shadow 10 feet long. A 5-foot tall woman casts a shadow 4 feet long. The triangle shown for the woman and her shadow is similar to the triangle shown for the tree and its shadow. How tall is the tree? And they are similar because the sun is constant for both the tree and the woman, so that forces the angle between the vertical line of the tree and or the woman and the horizontal line, which is the shadow. That's what causes them to be identical or similar. Okay, so they say, how tall is the tree? So if we wanted to solve this, we'd say that 4 over 10, which is the shadow of the woman divided by the shadow of the tree, is equal to 5 over x, the same relationship. The shadow of the height of the woman divided by the height of the tree, and x is the height of the tree. We're going to try to find how tall the tree is. So now that we've written the relationship, 4 over 10 is equal to 5 over x. We're going to do, it says here, to write the cross products. So the cross products say it's 4 times x is equal to 5 times 10. Okay, now we can carry that out to the next step. 4x is equal to 50. It says divide each side. What are we going to divide each side by? 4. So we're going to divide by 4 on this side, and we're going to divide by 4 on this side. So when you divide 4 by 4 on the x, on the side with the x, the 4's cancel, and you're left with x. And then x equals 50 divided by 4, which is, I would say, 25 divided by 2 is 12 and a half. So we're going to say 12.5. And this is going to be feet tall. And does it say round or anything? Let's see, similar to how tall is a woman? It doesn't say to round, so we're just going to say go with 12.5 feet tall. Okay, that's it. Okay, example 2. Check your understanding. Directions. A building 70 feet tall casts a shadow 150 feet long. A nearby flagpole casts a 60-foot shadow. Draw a diagram. Use similar triangles to find the height of the flagpole. So go ahead and do this on your own. Pause the video. When you come back, we'll do it together. Okay, I'm assuming you worked on this, drew the pictures, and gave it a shot. So let's do it. It says the building is 70 feet tall. So we're going to draw a 70-foot tall building. However that's going to look, we're going to draw a 70-foot tall building. Okay, here's our building. Here's the ground. Okay, and it's 70 feet tall. 70 feet tall from here to here. And it casts a shadow. And we're going to say the shadow casts from right this point here. And it casts a shadow out here, somewhere out here, 150 feet. So here's a 70-foot building casting a 150-foot shadow. And somewhere else on this property, maybe the flagpole for the building, has a flagpole that's casts a 60-foot shadow. So I'm going to draw a 60-foot. I'm going to go from here is where the flagpole base is. And we're going to say that this is the 60-foot shadow. I'm trying to look at the proportion of the size of the building shadow and the size of the flagpole shadow. So whether they're right or not doesn't matter. And so here is the flagpole. We'll draw a little flag on it. Okay, the flag is blowing. There it is. And its shadow is right here, cast by the sun coming down at the same angle. And boom, we get this shadow here. So what do they want to know? They say draw a diagram. We just did that. And use similar triangles. That's similar triangles to find the height of the flagpole. So what we're looking for is, let's say F, the height of the flagpole. So we know this distance here is 60 feet. All right? So what are our relationships? We know that we have a relationship of 70 feet to 150 feet on this triangle. They're similar, so we're going to use the same proportions. So 70 divided by 150 is equal to F, the flagpole height, which is equivalent to the building height, right? It's kind of similar in the building height, and the flagpole length, shadow length, which is 60 feet. Okay, so now in order to get this, we're going to cross multiply. So we're going to say 60 times 70, 60 times 70 is equal to F, or 150 times F, 150 times the height of the flagpole. So these two have to be identical. So this is 42, it's 100, right? So 4,200, if you multiply those together, we have 4,200 is equal to 150 times F. So we're going to go ahead, I'm going to move over here. We're going to multiply both sides by the reciprocal of 150. So we're going to be dividing by 150 in essence. So I'm going to rewrite it over here. I'm going to say 4,200 times the reciprocal of 150, which is 1 over 150, is equal to, so this is going to cancel 150 F over here, 150 F over 150. These 150s cancel. We're left with F, and F is equal to what? 4,200 divided by 150. And what is that equal to? So F is equal to, get out the calculator, 4,200 divided by 150, and I get 28. And the answer is 28. 28. So there's a solution. The flagpole is 28 feet tall. If this building is 70 feet tall, the flagpole is 28 feet tall. In order to have a shadow of 60 feet and 150 feet, as we're looking at it here, the flagpole must be 28 feet tall. 28 feet. Okay? Hope that makes sense to you. Objective 2, using scale drawings. A scale drawing is an enlarged or reduced drawing that is similar to an actual object or place. The ratio of a distance in the drawing to the corresponding actual distance is the scale of the drawing. And I think I mentioned this earlier in this review, and we were saying that the scale, like if you were measuring something that was 25 feet per inch, if on the drawing, every inch on the drawing stood for 25 inches in real life, the scale would be 25 to 1. That would be the scale. So let's go try, let's see what they're going to do here. Example 3, it's a real world problem we're going to solve here. The scale of the map is 1 inch to 40 miles. 1 to 40. How far is it from Atlanta to Athens, Georgia? It says, what is the map distance? That's what they want to know. How many miles is it from Atlanta to Athens? We're going to use the scale. Write the proportions with D equal to distance. So we want to know the distance from Atlanta to Athens. And we know that it's 40 miles per inch. And we know that we see from Atlanta on this little scale here, it's 1.5 inches. Okay, so from right here, you can see it. Right here, Atlanta, and over here is Athens, and it's 1.5 inches right there, 1.5 inches. Okay, so let's write the proportion. So we can write it any way we want. We can put when we write the proportion, we can say 1 inch to 40 miles, or we can say 40 miles to 1 inch. Either way is fine. They didn't tell us what we had to do. Okay, so I say we want to know, we're looking for miles, or the distance. So let's put the distance on the top. And the relationship that we know, the distance is 40 miles over 1. So I'm going to write 40 over 1 is equal to, so now we want d, the distance, right? It says use d for the distance, equals d, the d distance from Atlanta to Athens, divided by what? The distance on the ruler here, which is 1.5 inches. And I'm going to say 1.5. There's our relationship. Okay, so how are we going to solve this? We can cross multiply, and we'll instantly, as soon as we do the cross multiply, we'll get the answer, because we're going to say 1.5 times 40 is equal to 1 times d, because the 1 here multiplies 1 here, multiplies with the d, and then 1.5 multiplies with the 40. So 40 times 1.5 is how much? Well, 40 times 1 is 40, and a half of 40 is 20, so 60 is equal to d. And that means that d is equal to, I'm just going to, it's right here, 60 miles. I don't need to write it there. So Athens is approximately 60 miles. And why did we say approximately? We said approximately because we don't know. We look at this little ruler here. Yeah, pretty close to 1.5 inches, maybe a little smidgen less or a smidgen more. He didn't put the scale exactly. Who knows? It's pretty darn close. So it's approximately 60 miles. Okay. What is the map distance? We know the map distance. I'm going to answer the question is 1.5 inches. I guess we missed that and when I started talking about this slide. That little question right there. Okay, are you with me? If you have any questions, you know what to do. Just add a comment and I'll try to get to you. Okay, example 3. Check your understanding. Okay, it's your turn. The distance from Atlanta to Macon is about 75 miles. What's the approximate map distance between the two cities? Now they want to know what the inches. Okay, so we have the relationships going here. We know what the relationships are. So we know it's 1 inch. In fact, I wrote this onto the slide here from the previous slide so we would remember it. So we have, this time we want to find inches, right? We want to find the inches on the map. And what have I been saying? Put the number, the units that you want on top in the numerator. That way, because I'm going to say 1 inch in 40 miles is equal to, well, let's say the distance in inches. Well, we can still say distance or size. I'm going to write size. No, I don't know. I'm just going to say D for distance. D in inches over 75 miles. They told us how far it is from Atlanta to Macon. It's 75 miles. Okay, so now that we have that, we can do the cross multiply, and we're going to get these two will multiply, and these two will multiply. Okay, so we're going to get 75 multiplied by the 1 over here on this side, which is 75, is equal to D times 40. Okay, so now we have to get the D by itself, which means we have to divide both sides by 40. We can multiply by the reciprocal, 1 over 40. I'll do that this time. So 75 times 1 over 40 is equal to D times 40 times 1 over 40. Okay, these 40s cancel. And now I have 75 divided by 40. 75 divided by 40 is equal to D. And if we take it and we calculate that, I did it on my calculator. 40 divided by 75 divided by 40 is 1.875. I'm going to write it right here. Is equal to 1.875. And now if we convert that to inches and fractional inches, according to our scale, our ruler or whatever we're measuring with here, D the distance is equal to 1 7/8 inches. Okay? 1 7/8.